Thanks, everyone. So I present this talk on behalf of our research team. We have a eco-acoustic monitoring research group in KUT. So we collaborate with eco-acoustic researchers, and we are from the computer science part. So Dr. Harry Haynes, he's from Queensland government, like wildlife and parks. Okay, why do we want to do environmental monitoring? We want to do evidence-based decision making, and evidence for the environment comes from the field. So we do need to monitor our environment. So in Australia, monitoring our environment is even more important because Australia is far away from the other continents. And Australia, luckily, we have very unique plants and animals. So our biodiversity is very rich. So Australia is actually the southwest Australia and the eastern coastal area of Australia are two of the world's biodiversity hotspot. By biodiversity hotspot, we mean the terrestrial areas, they have extremely high concentration of biodiversity, but they are also threatened. So Australia, we have our very unique and very diverse local species. So that means that the species, they are only found in Australia. That you cannot find them anywhere else in the world. So they are irreplaceable. But unfortunately, many of our species are being threatened. And like for these two, so they are the Queensland, this one in Hunter Valley area. So these beautiful animals, like 100 years ago or 70 years ago, people can still see them, but now they're distinct. So and we have many more animal and plant species. They have distinct since the European settlement. More than 100 species have already got extinct. So we do need to monitor our environment, and we can use people, send people to the field to visually observe, to just listen with their ears, to monitor the environment. That's the traditional method, but they are very expensive. Labor force, and we rely on people's experience. And then now we have sensors, and sensors, they are getting cheaper and cheaper, and the performance is getting better and better. So we can afford to deploy many sensors into the field, and the sensors, they work 24/7. So we can, with acoustic sensors, we can afford to record environmental sound across large areas and for a very long time. So our groups have deployed, we call that Australian Acoustic Observatory. So we put acoustic sensors around all the important biodiversity places, and we will keep running for at least 5 years. Yeah, so we want to do, we can do acoustic sensing because animals, they actively produce sound for communication. So if I want to show you, so like koala is our iconic animals. So just wondering, just show you how many different types of sound koala can make. So the crunching, baby calling mothers. So you can hear a noise in the background. The male calling females. That's mating calls. And sometimes they also fight with each other, and they make a different sound. Okay, so we can record sound once we collect the data back, and then we can save them in databases. So QUT have our own high performance computing center. Then what we do about those data? So how can we get the insight from the data and then later on influence the decision making? So one way we do that, we just pass the data, collect the data, and then pass them to the ecologists or higher level decision makers directly. So that will give them lots of work. So as a result, the people will not look at that much data. So we collect them, they will sleep there doing nothing. So another way to do that for our computer scientists, we write algorithms using machine learning to do those some initial analysis and then pass them to ecologists to help ease their work. And the way to, another way we want to do that, because we cannot have enough experts to analyze data. So but we do have many general citizens, then they are willing to contribute their time to help us to analyze data. One way, we call them citizen science approach, or human computation approach to do data analysis. But the problem is these environmental data, they are very noisy and there are lots of different sounds in that. So you can test these bird calls. So one bird, this crow. So in this just 13-second audio, there are more than 5 types of birds in there. And each bird, similar to koala, they can, depending on their situation, they can create or produce many different types of calls. So these different type of birds, they do the similar thing. So sometimes, like in one type of bird, they can create more than 36 type of calls. For a general citizen to help us analyze the audio, that would be great. But there's also lots of challenges because the complexity of these sounds. So they are very noisy. One type of animal can make many different types of calls, and they also change. You know, these birds are similar to our people. They have accent. So the same type of bird in Queensland, when they move to Victoria, the call can vary. Yeah, so it's quite hard. So this one, so one type of our work is we are using machine learning to do automatic detection. It would be ideal if they work. The problem is because these the environmental audio, they are very noisy. So machine learning analysis, the accuracy currently is still quite low. So we turn into how we can have our general citizens, so how we can motivate them and to help, so they can help us to do some analysis work. So many people, especially like these environmental enthusiastic people, like many Australians, that they like bird watching. They like to go to the field to spot specific animals, very important plant species. But still, so if we involve a large team of people to help us to do the data analysis, and the quality varies. So like we collected the data, and we assume we have many people who are willing to help us to analyze the data, but the quality varies a lot. So how we can trust the quality of the data? So this our research is we explore different methods. So one is we use reputation modeling. So while we given the citizens a piece of data to ask them, or multiple pieces of data, and ask them to help us to analyze the data, we can embed some known data. We know the right answer, and then some others we do not know the answer, and then by observing how many known answers they got them right, we would know their knowledge level, their experience level, so then we can build a reputation model, and then later on we can use that to control the data. And the other approach, so that's we do collaborative analysis. So this is if we want people to do, to help us to analyze data, asking them to listen through the audio will take very long time. But if we turn the audio into images, and people can look at the images very quickly. So that is why we want to create the visualization of the audios, and we provide these libraries. So if you, every time you see this type of call, it's this green fantail. So that can speed up the process. So, and the other one, to increase the analysis of the quality, we ask not only one person, but a group of people to look at the same piece of data, and they can discuss. So using data social logic, so we can increase the quality of the analysis. Okay, so in conclusion, we can use different type of approaches to try to increase the quality of the data analysis, but we are still not there yet. Yeah. Okay, good. Any questions?